My name is Iket. The topic that we choose for our assignment is Smart Door Lock System using AWS. First, I'm going to talk about the background study of Smart Door Lock. The origin of keycard locks can be traced back to a Norwegian engineer, Thor Solnes, who invented the recordable keycard lock in the 1970s, offering enhanced security for hotels and leading to the development of electronic lock systems. In the early 21st century, wireless communications, biometrics, and microprocessors enable the creation of smart door locks and integrating the features for remote control, monitoring, and automation. In the left side is an example of the recordable keycard lock invented by Thor Solnes. It can contain 32 holes that transform into over 4.2 billion different combinations. And the right side is the smart door lock with advanced features. For example, we can use the mobile apps to unlock the smart door lock. There are three reasons that drive the market growth of the smart door lock. The first one is the rise of the smart home industry, and the second is the increase of home security awareness, and the third one is the popularity of smartphones and mobile apps. The global smart door lock market was valued at $2.3 billion in 2022 and is projected to reach $10.5 billion by 2032. There are some future trends of the smart door lock. The first one is the focus on improving the security features, and second is expanding the compatibility with the smart home ecosystem, and the third one is enhancing the user experience through the voice control and remote access. There are three current technologies widely used by the smart door lock. The first one is the biometric sensors, which consists of fingerprint recognition, facial recognition, and iris scanning, which is to offer the secure and personalized access by utilizing the unique biological characteristics. And second is the wireless communication, which consists of Wi-Fi, Bluetooth, Z-Wave, NFC, RFID, or more other examples. This communication enables the remote access, keyless entry, smart home integration, and communication with various devices. And the third technology is mobile apps and digital assistant. Mobile apps enable the remote control, management, and monitoring the smart door lock through the mobile apps, while the digital assistant integration offers the voice control and smart home automation. This is the smart door lock architect diagram for our assignment. In this my assignment, we had used 5 AWS services for it. The first service is Amazon Next. The second is Amazon DynamoDB, and the third one is Amazon EC2, and the fourth is AWS Lambda, and the last one is Amazon SNS. So at first, the user can use their mobile device to interact the Amazon Next, where he or she can send the username and access code to the Amazon Next. So the AWS Lambda will validate the username and access code provided by the user by retrieve the user info from the Amazon DynamoDB table we have created. The table we have created in the DynamoDB is user info table, where we will store the username and access code of the user. So if the input provided by the user is correct, it will unlock the door for the user and the access will be granted to the user. But if the username and access code provided by the user is not matched with the record in the DynamoDB table, it will ask the user to send the username and access code again. And after that, if the user wants to generate the random access code, it can ask the Amazon Next to generate a random access code for he or she. And the AWS Lambda function will trigger the Amazon EC2 to generate the random access code. We have created a random access code generator in the Amazon EC2. So after that, the Amazon EC2 will generate the random access code, and the random access code will be sent through the Amazon SNS separation by using the email of the user. So you can see that the Amazon SNS will send the access code through the email to the mobile devices of the user. And so that the user can interact the Amazon Next by sending their guest access code.
Hi, my name is Kudiho and I'll be presenting the problem statement for our topic. So there's a growing need for secure access to homes, office, and other premises. The technology advancement today has been improved a lot, therefore the smart door lock system demands quite heavily. And the traditional lock systems lack scalability and flexibility, so there is a need to be integrated with a cloud platform such as AWS to enable it for remote access control, real-time monitoring, and data analytics. And the system should be secure, reliable, and easy to use. So now I'll be presenting the comparison of cloud services. There are three different cloud services, which is AWS, Google, and Microsoft Azure. On the computer services, AWS offers the largest variety of instance and configuration, and Google has the advantage of Kubernetes for container orchestration. On Microsoft Azure, it has the advantage of hybrid cloud support and strong focus on Windows-based application. For storage, AWS has Amazon S3, EBS, and Glacier. For Google, Google Service, which has lower latency and performance. For Microsoft Azure, it offers similar storages like AWS. And for database, AWS offers relational, non-relational, and in-memory database. For Google, it specializes in cloud-native database such as Cloud Spanner and Firestore. For Microsoft Azure, it offers SQL database and Cosmos DB. And for the chatbot, AWS is Amazon Lex. For Google is Google Cloud Dialogflow, and for Microsoft Azure is Microsoft Azure Bot Services.
My name is Chun Singh, and now I will be presenting the future work of the smart door lock system. Smart door lock systems have rapidly evolved with advancements in technology, offering enhanced security and convenience for homeowners. Biometric authentication, connectivity, and artificial intelligence, which is AI integration, are key features of future smart door lock system. For the first one is biometric authentication. Biometric authentication, such as fingerprint recognition, facial recognition, and retina scanning, eliminates the need for the traditional keys or PIN codes. And it also provides an added layer of protection against unauthorized access, ensuring the security of the home. And enhance security by utilizing unique physical characteristics of individuals for access control. So now for the second one is the connectivity. The integration with the internet allows homeowners to remotely control and monitor their smart door lock systems using smartphones or other connected devices. And it enables features such as remote locking and unlocking, access control, and real-time notifications. And it provides increased convenience and flexibility in managing access to the home, even when not physically present. So next one is the AI integration. AI algorithms can learn from user behavior and patterns, adapting the lock system accordingly for personalized and intelligent security solutions, recognize typical access patterns, and adjust security settings accordingly. And the voice recognition technology can provide convenient and hands-free access control. For the challenges of the future smart door lock system, the first one is the privacy and security concerns due to the internet connectivity and use of biometric data. The second one is the adoption and integration with existing hardware infrastructure. And lastly is the reliability and durability and in harsh weather conditions and potential technological glitches. Now I'm going to present a DynamoDB how to use it to create table to store user information. Now we will come here and press create table. Then table name we will give user info. And the partition key we will give user name. And the sort key is access code. So both of them is string. And in the below here, we will choose default settings. And now we will press create table. So we already create, so cancel it. So in the tables here, it will show the user info, the table we will create just now. So we will press inside and then go to the explore table items. And in the below here, we will press create item. So here is just now we create one, the username access code. So we put the name, for example, John, and the access code is 2023. And then after that finish, then we create item, but we already create, so we cancel it. So here it will, after create, it will show it at here. So that is the item that we create for the DynamoDB.
So I'll be demonstrating the add lambda function. So before you create a lambda function, you have to create roles in the identity and access management IAM. This is the dashboard, and this is the 15 roles that pre-created by us. And then this is the roles. To create role, you have to press the create role, press the entity type, the use case such as lambda or EC2, press next, and then choose the policy and then next. That's all. So after that, I will demonstrate the lambda. You have to search here lambda and then it will pop up such as this, the dashboard. And then you press functions. This is the two functions that created in the lambda. This is validate access and this is the code. So this lambda is used to validate the existing user name and access code, and then it will unlock the door or tell the user that it is invalid. You have to enter a user access code again. Then this lambda function is to launch the EC2 and connect the SNS. This is for the guest user. And then this is the code here. When the guest user wants to log in, it will send an access code to their email or something, and then the user can use the chatbot from such as Messenger or the door lock or something and unlock the door using the access code sent from the bot through their email. That's all from me.
Hi, my name is Tan Bonde, and now I'm going to present the part where using SNS service and also EC2 services to integrate with Amazon Lex chatbot for user to get a random generated code to unlock the door lock. First, we need to create a new EC2 instances for our Amazon Lex chatbot. We go to the EC2 management console, and under the instances, we click on instance and click on launch instances to create a new EC2 instance. Enter a name, for example, like guest code generator, and after that, leave everything in default settings and click on launch instances. After creating the instances will appear in the instance table and users can click on it to view the instances summary, for example, like the instance ID and a public IPv4 address. Now let's move on to create an SNS topic and also the subscription. Under the Amazon SNS, click on topic, create a topic and choose standard because we are using AWS Lambda to connect with. Create a random name, like another example is guest code, and click on create topic. After creating a topic, click on subscription tab to create a new subscription. Click on create subscription. Select the topic ARN that we have just created and select a protocol email and enter a email and click on create subscription. After that, The status here pending for confirmation, so we need to go to our email to accept the confirmation. As you can see here is the AWS notification subscription confirmation. Click inside and click on confirm subscription. When this is prompted, it says subscriptions confirmed. That means we have successfully created a subscription for our SNS topic. Now I'm going to explain the Lambda code function for our Amazon Lex, EC2 and also SNS. First, we extract the user's input from our Amazon Lex chatbot, and we will then create a EC2 client and specify the EC2 instances that ID that we have just created, and we start the instance once the code is running. And we will use a Python code to generate a random 4-digit code for our guest users to unlock the door. And next we will create a SNS client and specify the SNS topic ARN that we have just created to publish to. And then we will publish a message of the code to unlock the door is the random code that we have just generated, and we will publish the message to our email. And lastly are the Lambda validation and also initialization for our Amazon Lex to ensure that users enter the correct guest code to unlock the door. Now we are at the Lex version 1 console, and here is our chatbot that we have created for our system. And inside the chatbot, we have two intents, and we click on our second intent, which is to unlock the door as guest. And inside here, we create a sample utterance. For example, I want to unlock the door as a guest. And we, under Lambda initialization and validation, we select our Lambda function and also select our alias for the particular Lambda function. And under the slot, we will just create a slot type of Amazon number, because we generated our code in 4 digits integer, and then we will just prompt the user to provide the guest code that is being published into our email. And under fulfillment, we will just again select our Lambda function and also the same alias. And after that, we will just save the intent. And after that, we will just build the chatbot. After the smart door lock bot build was successful, we will then publish our chatbot using an alias for our Amazon Lex chatbot to publish it to our Facebook Messenger. After the chatbot was successfully published, then we click on go to channels, then we select Facebook, and then from here we will going to activate a callback URL to use the Facebook Messenger in order to integrate our Amazon Lex chatbot with our Facebook. We are going to skip the steps to integrate with our Facebook, so let's jump right into our demonstration. So here is our Facebook page and our messenger bot that is being integrated with our Amazon Lex chatbot. So I'm going to demonstrate the part to unlock the door as a guest. So we just ask our chatbot, I want to unlock the door as guest. And after that, the chatbot will ask us to provide the guest code that's being published to our email using SNS. And now we are going to see what is the code. And as you can see, the AWS notifications, the code to unlock the door is 6534. So we just enter 6534. So the guest code matches the email random code. So the door lock has been granted access, and you thank you for using the services. And that is all for my part. Thank you.
For the Amazon Lex configuration, we have created a chatbot which is named as Smart Door Lock Bot. We have created two intents for the chatbot. The first intent is unlock door, and the second intent is unlock door as guest. The function of this unlock door intent is to let user to provide their username and access code to the chatbot, and the chatbot will validate the username and access code sent by the user to see if it matches the record in the DynamoDB table we created recently, which is called as the user info table. The function of the utterance is to let user to invoke the intent. So for this example, we have created a sentence for the utterance, which is I want to unlock the door. And the lambda function we have selected for the initialization and validation is validate access lambda function. And we have selected the latest version of it. We have created two slots for this another intent. The first slot is username, and the slot type we selected is Amazon.us first name. And the prompt for this slot is please provide your username. And the second slot we have created is access code. The slot type we selected is Amazon.number, and the prompt we have created for it is please provide your access code. For the fulfillment, we have selected the AWS Lambda function, and the Lambda function we have selected is validate access Lambda function, and we have selected the later version of it. And the second intent we have created is another.sgas. The utterance we have created for it is I want to unlock the door as guest. For the lambda initialization and validation, we have selected the launch EC2 and connect SNS as the lambda function. So for the lambda function, we have selected the AWS chatbot as the version for it. In this intent, we have created a slot. The slot is called guest code, and the slot type we have selected is Amazon.number, and the prompt we created for it is please provide your access code from email. So for the fulfillment, we have selected the AWS Lambda function, and we have selected the launch EC2 and connect SNS as the Lambda function, and the AWS chatbot as the version for this fulfillment. To enhance the mobility and user experience of the smart door lock bot, we have integrated the chatbot into the Facebook Messenger, which is called an AWS chatbot. For example, I can interact the chatbot by sending the message, I want to unlock the door. And the chatbot will ask the user to provide the username. So I have created a record in the user info DynamoDB table. So and for the username is called John, and the access code for John is 2023. So you can see that the access was granted and the door has been unlocked now. So the function of the chatbot is to validate the user info provided by the user input to see if it matches the record in the DynamoDB table. As you can see, the user input provided by the user is matched with the DynamoDB table. So that's why we have granted the access and the door has been unlocked.